The broadcast is now starting. All attendees are in listen-only mode.
Hey there, everybody. Luke here again with our third installment of Inventor 101. And what we're going to talk about this week is we're going to wrap up sketching. We did a lot of that last week. We're going to cover a few more things with sketching, and then we're going to jump right into all of the feature tools. So extrude, revolve, sweep, loft, all those different things that you use to create all the different geometry that you need to do. Just as a side note, I got some emails this week and the week before. This is not a replacement for training. Someone was asking about certificates. Well, I hope you get a lot out of this. This is really kind of high level training to kind of get you directed in the right path. I highly recommend you reach out to one of our partners perhaps, or maybe look online to get that in-depth training that you need when you're running any kind of software program. So let's jump right in and get started. So let's set this back over to the resources. And on the screen there's a list of resources that you can go to so you can get the trial if you're not already running Inventor. We have some projects that go along with the trial that you can check out. We have our What's New page, which lists all the stuff that is brand new in Inventor and ideas in the forum. So make sure you get engaged with the community and participate, because that's where all the magic happens with Inventors, whenever you folks help us make it better with each release. Okay, let's jump right in. We are going to be making some parts today, and we're going to stick with millimeters today. We talked about projects in our first episode, so if you want to check that out, you can check out, it's online. If you go to the YouTubes and you look for Inventor Luke, the first Inventor 101 class is there. That shows you how to set up your projects and what to do with all your data. So we're going to wrap up sketching, and just to get us back to where we were, we always want to build stuff on 0, 0, so I'm just going to put a quick sketch on 0, 0, and I am going to just do a quick 2-point rectangle. And what I want to talk about are some additional sketching tools that you might run into. So I've been running Inventor for a really long time, and I've probably only used a handful of these commands. It's really kind of personal preference. But the thing I will tell you is, when you can use some of these quick automation tools or the quick tools to draw things, make sure you do that. So for instance, let's say that I need to create kind of a more complicated shape here, all square shapes, maybe some different rectangles, different protrusions, whatever you happen to be making. Maybe you're making like a little PCB board diagram or a layout. So rather than just trying to sketch this all the way around, when you use a tool like 2-point rectangle, it puts all the horizontal and vertical and all the constraints on there for you, so it's super quick. Now there's a command called trim. So this is just like the command in AutoCAD. Those of you that are AutoCAD users, works just like the trim command in AutoCAD. You could just hit X on your keyboard. That's what I do. Hit escape, get out of your command, and hit X, and then basically you pick what you want to get rid of. So I want to get rid of that, that. And basically it's a super quick way to take geometry and trim that geometry up. It also works as an erase command too. So if you accidentally pick a line, see what it's doing here. It actually infers where I want to trim to. So I'm not sure if you're seeing this on the screen. If I pick right here, it's going to think I want to trim to where that would intersect. And if I do it this way, it does the same thing. So all of this trimming, even if it's not connected to that piece of geometry, if it's horizontal or vertical, it's going to do that. So I'm just going to do a quick undo on those last few. So so make sure that when you're using that trim command, just be careful when you're doing it. You can accidentally maybe delete or trim out some things that you don't want to trim. Another command that is super helpful inside of this is the ability to just kind of add automatic dimensions. So you kind of roughed it in. You don't feel like issuing all the different dimension commands. when you issue this auto dimension and constraint tool, it basically goes through, looks at all the geometry you have, and it applies all of the different dimensions and constraints necessary to basically constrain that completely. Just a quick reminder, as you're listening, if you have questions, just ask those in the question panel. We have James on the line helping out field questions with me, so if you have a question, ask it in the questions. He will interrupt me, I'm sure, and ask those questions. So make sure you get them in there. If you have anything, just put them in. If we don't get to the questions today, we will answer them either directly via email, some of you emailed last week, or we will put them up on some of the social channels to answer those questions. So make sure you ask them in the questions panel. So it tells me that it's going to add 12 dimensions, it's going to add the constraints. I'm going to hit apply, and basically what it does is it throws on all the dimensions. Now what it does, it doesn't do it maybe in the neatest fashion, but I'm not one for really worrying about my dimensions, especially in my drawing, my sketch view. I mean, I can always drag these and position these somewhere else if I want to. So I highly recommend the automatic dimensioning tool. Now you may want to come in here and delete something. For instance, there's a few things that are constrained to 0, 0, this 8.1 and 71. I probably would delete these two, and then I would probably use a coincident constraint and just put that corner and that corner to lock this in place. Another really cool tool that comes in handy a ton, and I use it a lot, is the offset command. And this, again, just like the offset you would think, what it does is it does a chain. So it basically picks anything connected and creates that offset. You can go to the inside. It does allow you to do overlapping. I take that back. I thought it did. It didn't. It will let you offset to the inside. Now check this out. When I go to dimension this and I make this 5, it takes every single line and offsets it 5. So it knows that you built that offset in that particular fashion and treats all of that geometry the same way. So super quick way to create different types of geometry. So now if I want to extrude this, rather than doing this with an extrude and then a second cut after the fact, this is a perfect example of when you may want to use sketching to create that geometry rather than doing 2 different features. So again, keep that in mind. So the offset command, great command. Another way to create dimensions and work with dimensions, this is a tip I actually saw someone talking about the other day, which I thought was a really good one. And this is what a driven constraint is. So I'm just going to clean this up. And let's say you have a 2-point rectangle. I'm going to project my center point because I deleted it. So sometimes you don't know exactly what your dimension is going to be. I can actually create my dimension, make it, whatever I want to make it. Let's say this is going to be 80 millimeters. And this is going to be, let's say, 20 millimeters. And what I can do is I can actually turn this into a driven constraint. So I can come in here and I can turn this into, and I'm missing it right now. Why am I'm drawing a total blank on where my driven constraint is, or my driven dimension. Wow, that's, I'm gonna have to come back to that. I just pulled brain cramp, sorry about that. Remind me to come back to driven dimensions there, James. So the next thing I want to talk about is this rectangular, circular, and mirror patterning. So let's say, again, we are in our sketch and we want to create some geometry, and I'm just going to come in here and dimension. let's say that's going to be 10, and we're going to locate this off of these edges. We'll say 5 and 5, and let's change that to 5 as well. I can do a circular or rectangular pattern, so I can choose my geometry, I can choose the direction I want it to go, my second direction, I can flip-flop that direction, and then I can say, you know, I want there to be 5 of these by 5 of these. You can do this in a sketch and create this type of geometry. And then I can come in here and, you know, do my extrude. The challenge is when you create geometry and you put all of the detail of that particular feature in the sketch, to modify it, you have to go back to the sketch. We didn't talk about this a whole lot last week when we were talking about sketching, but you know, where's that hole command? Where is that pattern command? So it makes for a browser that doesn't have lots of features, but what it makes for is it puts a lot of stuff into one location and can make it difficult to find and to edit, because now I have to come back in, I have to edit the sketch, and whenever I go to change these numbers, you know, it's going to now just require more of an effort, where probably the best way to do this one, and the way I would do it, is I would locate the dimension. I actually wouldn't even do that. Take that back. I would actually extrude this. I would issue the hole command, because remember, we talked about this the other day. We did concentric placement the other day, but I can place a hole, pick how big I want that hole to be, and then I can choose my linear reference. So I can say from this edge here, whoop, helps if I issue the command correctly. So from this edge here, it's going to be 10. And I keep on hitting enter instead of apply, and I can set it there. So once I have that, that's actually a feature now that I can edit. So it's a whole lot easier to change that. I can make that a countersink. I can really change a lot of different things about that hole. Now I have that exact same list of tools for patterning. I can do rectangular, circular, I can mirror. So now whenever I do that rectangular pattern, I pick that feature, I pick my first direction, I pick my second direction. You might need to flip just like we did before. I'm going to have 5 of these, or let's say 4 of these, and I'm going to have 7 of those. So now what I end up with is a much more intelligent component that I can work with. So now I have the rectangular pattern I can easily edit and the hole command. So again, yep.
Could you take a quick step back and show us where the auto dimension tool was at again?
Oh, yeah. Let me take that back to here. Actually, you know what, let's just, I need a new file anyways. So yeah, the auto dimension tool is really great whenever you kind of roughly know kind of what you want your geometry to look like. So let's do a new sketch, and we'll do that 2-point rectangle, and we'll do another one here, and we'll trim this and clean it up. So I could go through and throw all my dimensions on here, but right here beside dimension in the constraint toolbar, it's the lightning bolt, automatic dimension and constraint. Issue the command. It automatically looks at the sketch. You could go through and pick and choose what you want to do, but by default it grabs everything. Just going to hit apply and done, and it adds all those dimensions. And again, you probably want to delete these dimensions that go to 0, 0, because you probably want to do that with a constraint. I'm going to use, let's say, the horizontal constraint with that, and the vertical constraint with that and that. So now this is totally locked in. Alrighty, good question, and I use that a ton, because now all I have to do is edit my dimensions to kind of get this back in shape to where I want it to be. It can throw things off, so if I wanted this to be a super small component, let's say I did this automatic dimensioning and my overall length is actually, you know, 20, whenever I change these values, it gets all kind of discombobulated. So usually you have to kind of have an idea of the rough size you're sketching at for this to work a little bit better. So just something to keep in mind. And
is this only in 2018, or maybe it's moved to a different location from a previous version?
It's been around a while. It's definitely not a 2018. You may have a customized toolbar or something like that, but it should definitely be underneath the constraints. So again, right beside dimension. Yeah, on the sketch tab too. So make sure you're on the sketch tab with everything else.
Thank you.
No problem. Okay, so that pretty much wraps up sketching. I want to make sure we save the balance of this time for working with the different features that we have access to inside of Inventor. So the first one I want to talk about is the Revolve command. And we talked about some of these tools the other day. But the centerline tool is a great one. So if I draw a line on 0, 0, because you typically, again, want to keep stuff on 0, 0, and you turn this into a center line. So if you go over to the centerline command, and I'm going to pick the line and then issue centerline, it's going to turn that into a dashed line. Now, when I create different types of geometry, it's going to assume that that is my, do a little arc here, we'll go there and there. I'm going to just do a quick auto dimension on this. I might delete some of these dimensions if I don't want them. I really don't need the dimension to be on these lines here. It picks up and puts a diameter dimension on for me because it knows there's a center line. It puts on my radius dimension, all the dimensions that I need to locate this basically. It does for me. Now, whenever I just change this to 42, that's my even number I want to change this to, and I issue the Revolve command, I'm going to hit R for Revolve, or I could finish the 2D sketch, and then I could issue the Revolve command. So the Revolve command, if you have a center line there by default, what it's going to do is it's going to automatically pick that center line up as your rotation axis. If you don't have a center line, you have to choose it after the fact. It's 6 to 1, half dozen to the other. So whichever way you choose to do it, but it does make it a little more automatic with the center line. Now, when you're doing the revolve, you can do a lot of different things with the revolve. So you can do a full revolve. You can do an angle. So I can choose to revolve this 90 degrees. I can revolve it the other way. I can split the difference. I can do an asymmetric revolve. I can go 90 degrees one way, and then I can go a different degrees the other way. So a really, really cool piece of functionality here. The other thing, too, that you'll notice is the output. So this is something that most of the feature creation tools in Inventor have. By default, you're creating a solid model. So that's why it is set to solid. But if you wanted, you could create a surface if for some reason you're creating a bunch of stitch surfaces that maybe later on you will knit together and turn into a solid. All depends what you're doing, but probably 95-98% of the time you are going to be creating solids. So now I'm going to just do that same that same command. Oh, I'm sorry. I'm going to hit OK rather and issue my sweep command, or my revolve command rather. So what I could do now is I could come into this sketch. Let's say I want to create some additional geometry. I'll show you another way of doing this. Maybe I want to sweep this so that it's hollow perhaps. I can put a sketch on this face. You can see 0, 0, 0 is projected, and I'm not going to do this with a line. What I am going to do is I'm going to project geometry. I'm going to pick this face, and I'm going to do an offset. I'm going to start mixing and matching some of these. I'm going to delete some of these lines here that I don't want. I'm going to extend. This is another one, so the opposite of trim allows me to extend a line, and then I can trim a line. So what I can do now is I can issue my revolve, but it doesn't pick up the axis. So what I have to do is I have to choose axis, and because I built this on 0, 0, I can actually choose one of the origin axes. This is another good way to keep your sketches and keep your geometry pretty clean. I didn't have to edit or add additional geometry, so I will add in, whoop, there we go. Give me 1 second. Did something I didn't like. Do you have any questions for me, James, while I'm coming back up?
No, not right now. I've been fielding them all for you. Don't worry.
Oh, I appreciate that.
I'll let you know if any more pop up, though.
Okay, perfect. Okay, let's try that again. So we will do a sketch. And I'm just going to do that rectangle, and I'm just going to do a quick revolve. I don't even need to dimension it if I don't want to. And we will do angle 90. There we go. Okay, so where I was before was I wanted to put a sketch here and revolve that again. So when I put a sketch here, I'm going to issue my project geometry. I'm going to offset that geometry. I'm going to revolve this. Now, almost every feature creation command has a join, a cut, and an intersect. So if you think about when you're creating your geometry and how you want to do things, in a lot of cases you create like if you were going to be machining this. So I could have sketched this with this pocket in it and then did the sweep at one time, and the pocket could have been there. I tend to create my models, not always, but the way you would actually make them, the way you would machine them. So typically this would probably be a large chunk of metal that you would cut a hole in, then do a second operation. So that's why I tend to build things with multiple operations. So now what I'm going to do is I'm going to do a cut. I'm going to pick that axis again, and when I go to cut this, it's going to create that geometry and do that cutting operation. So what I have now, rather than one revolve with a more complicated sketch, I have 2 revolves with relatively simple sketches, and that's, again, best practice, usually the way you want to go about creating your geometry. So the next one that I want to talk about, shoot, you got another question?
Yep, real quick. What would you say are the pros and cons of sketching on a plane versus a face? Like, do you get more control one way or the other? Is it just about geometry manipulation?
Yeah, good. Yeah, so good question. So if you can sketch on any of these origin planes, so I'm going to turn these and make them visible for a second. If you can sketch on these, it's a good best practice to sketch on the origin planes if they're available. But in some cases, they may not be available. So for instance, if I want to create something on this face, the closest plane is this XZ plane, which is in the middle of the part. So in some cases, you have to create the geometry on the face of an object rather than an origin plane. You could come in, and what some people do is they will add planes. So you could come in here and I could put a plane on this face, and I could say, offset of 0, and then I work on that plane. That's just an extra step. I've seen a lot of people do this, and then when they create their sketch, they put their sketch on the plane itself. It's not a bad practice, but it's just an extra step because that plane's going to move when that geometry changes because the plane is built on the geometry.
So you're not necessarily getting any extra functionality or anything like that. No. It's kind of like the surface of that part would become a work plane in its own.
Exactly. Now, you may get into a situation where you have a really complicated location to create stuff on, and I think maybe next week, we might get to it a little bit this week, but I want to make sure we get through the rest of these features. You may have to create a plane that is, maybe parallel through an axis, maybe it's 45 degrees, And if I want to work on this curved surface, you can't sketch on a curved surface, right? But I could take a plane parallel to that, tangent to that face, and now I can actually work on that curved surface right there. So sometimes you have to create planes to do the different things you want to do to your models. So yeah, so planes are your friend. You're going to create a lot of work planes when you are modeling with Inventor. It's just the way it is. Okay, so the next one I want to do is I want to make sure we talk about sweep and loft. So the sweep command is a pretty interesting command. You need a profile, and then you need a path to follow. So the profile can be just about anything you want it to be. So I'm going to create just a 2-point rectangle. We'll put a few dimensions on this, 1.5 by 1. I am going to constrain this vertically and horizontally. Always build your stuff on 0, 0. Then what I want to do is I want to create a path now. So I'm not going to do a feature creation command. I'm just going to finish the sketch, and I'm going to now do a sketch that ideally passes through the center of this object. It doesn't have to be the center of the profile. I could pick the corner, I could pick a midpoint, but ideally if you have a profile that you want to sweep, let's say this is going to be, you know, maybe a bent piece of square channel that you're going to have. Ideally it's at the center of this. So I'm going to do a sketch on that plane, and now what I'm going to do is I'm going to create the path I want this to follow. So I'm going to come out here, let's say 6 inches. I'm going to create a curve up to here. I'm going to create another 3-inch line there. I'm going to do a curve, and it can be as complicated as you want it to be. I'm going to finish that 2D sketch. And now what I'm going to do is I'm going to sweep this along that path. So when you issue the sweep command, the first thing it asks for is a profile that picks up that closed profile. The next thing it asks for is a path. Choose your path, and you can make it parallel to the path or follow the path. The parallel path kind of gives you an odd profile. I've only done that one maybe once or twice. I could have this taper if I wanted to. I could add guide rails. There's all kinds of options in here, but I'm just going to have it follow that path. And now what I can do is if I wanted to, I can start to add some additional features to this. I can, you know, add in some fillets. Again, you want to do fillets at the end. I could have drawn the fillets in the 2D sketch, but I want to have control over those fillets. Now I'm going to issue the shell command. So this is another really cool command. You know, let's say you want to have a hollow component. Maybe you're making a piece of tube or a pipe or a channel, something like this. If you issue the shell command, what it does is it basically looks at the model, chooses a wall thickness. 0.1 is the default. I can actually choose to make that anything I want, but you can see the wall thickness. And what you want to do is you want to remove faces. So I'm going to choose the end face here, and then I'm going to choose the other end face. I'm going to hit OK. And now what it's going to do is remove those faces, and now this is going to be a hollow. Let me change my view up. I always yell at people for doing stuff with kind of oddball colors. But what you can see now is this is a hollow component created with that shell command. So lots of different pieces of functionality here just with extrude, revolve, and sweep. The next one that I want to make sure we talk about is the loft command. And loft is exactly what you think it is. So if you think of a sheet metal transition, this is probably one of the most common things that I've seen people do in training when you're trying to teach the sheet metal command. And I'm just going to create, again, a brand new part file. And I'm going to start with a sketch. Always start with a sketch. And we are going to, I'm just going to locate this right here. We're going to make this, let's say, 12 inches by 18, and we will do a horizontal constraint and a vertical constraint. So now what I want to do is create multiple profiles that I'm going to loft to. So I'm going to finish the sketch, and here's where you have to start to create some work planes. So if I need a plane that is parallel to this, but then off, let's say 12 inches or 18 inches, I'm going to do a work plane. It's parallel to this XY plane. This is the plane that you're working on. And I'm going to move this back. Actually, we'll go positive. We'll say positive 18 inches. So what it does is it puts that plane 18 inches forward. I'm going to do another one of these off of this one. So you can build planes off of planes. And this one is going to be 8 inches off of that. So I have these 2 or 3 profiles now that I'm now going to sketch on. So I'm going to put a sketch on this face now, and I'm going to just draw a real simple circle with a 10-inch diameter. I'm going to finish my sketch, and my last sketch is going to be here, and I'm now going to go to a smaller rectangle. This is going to be 12 by 12, and we'll do our horizontal and vertical constraints like we always do. Everything's fully constrained. Let's actually make that one a little bit bigger. Let's make this 24. There we go. So what I'm going to do now is I'm going to loft from one profile to the next, and there really isn't a limit to the number of profiles. It's just a matter of choosing them. And by default, since I don't have a rail to follow, because this is kind of a linear loft, it just goes in one direction, I'm just going to choose them in order. You can see what it starts to do. And it starts to create a pretty complicated piece of geometry. Now, you can do all kinds of different things with this. You can have this follow a center profile. You can have this go, through a center line. You can have it follow some rails. I'm just going to hit OK and show you what the default looks like. Now, the neat thing about this loft command is you can come in and start to modify different conditions. So I have 3 different sketches here. I can start to change the weight and the transition of these. So from one sketch to another sketch, I can change how that angle comes off of that sketch. And I can do the same thing with that one. So what that does is it gives me a weight that it comes off of that angle, and you can start to see that you can create some really complicated pieces of geometry. And again, I'll edit that feature. I'm not sure what that merge tangent edges did. That just turned that thing inside out. That's really odd. We'll undo that. So really interesting tool there. Again, I can shell this. So if you wanted to create a shell of this, I can pick those 2 ends. I can shell this out, and now I have a pretty complicated transition. I don't think you'd ever make a piece of ductwork look like this, but so the loft command allows you to go from one to the next when you're creating those, and you can also create centerline paths if these things go kind of out of plane. So really great tool there with the loft command. There are basically 2 or 3 more that I want to cover, and then I want to leave a little bit of time at the end for some questions if anybody has any. So we're just going to create a brand new, let's go back to this part here, and the command that I want to talk about now, this is the fillet and chamfer command. We talked about this the other day and just a minute ago about making sure that you do all of your fillets at the end. The interesting thing about fillets is they create different look and feels when you do them in different orders. So you have a couple different options inside the fillet command. We're just going to talk today about the default fillet command. And this is just a constant radius fillet, meaning if you put in a 0.125 fillet, it's going to be 0.125 the entire length and transitioning of that fillet. So whenever I pick the fillet, I get a dynamic preview, and anytime you can create what I call chains. So ideally, if I am ultimately going to fillet this top edge, what I want to do is I want to fillet all of these vertical lines first. Then I can come in here and add my two top and bottom fillets. And you notice what the fillet looks like. If you do these in a different order, you get a different result. So if you remember what these corners look like, I'm just going to hit undo a couple times. If I fillet this angle first, then I do this one, you can see I get a totally different look and feel depending on when I do my fillets, how I do my fillets. So depending on what you need that end result to be. So maybe I don't need these fillets on these vertical lines done. I would just have to fillet, all of these top edges first. And again, you get a totally different look and feel to that model. The other thing too that is on by default with your fillets, and I'm going to fillet these verticals. So if I fillet all my vertical edges first, there is an option for selecting an edge or a loop. So if I do a loop, it's going to automatically pick anything that it can. If I pick an edge, so if I issue that again, and I pick an edge, it's going to take any tangent edge and fillet that. When you add that loop function, so if I turn loop on and I pick it, it finds anything that it can loop, and it does. Another quick way to do fillets, so if you ever need to knock off all the edges and all of so you have maybe like a cast component and you want to put a small round on everything. If you issue the fillet command, you can add all fillets and all rounds. And what that's going to do, let me bring this Revolve back. We'll use this. Whenever I do all fillets, that's all the internals, because fillets are internals and all rounds are external. And it's a quick way to create geometry where I don't have to go through and pick all those different edges to create that fillet. So lots and lots of options just with the regular constant fillet. Next week we're going to talk about variable radiuses. We'll talk about full face fillets. We'll talk about all kinds of filleting options along with some other topics next week. But something I did want to show too, and this is new in 2018. So if you have an earlier version, you may not have access to this. But the chamfer command now has a partial chamfer option. So by default, whenever you do a chamfer, kind of looks like that. Everybody kind of knows what a chamfer is. Nothing crazy about that. But what you can do with 2018, I'll undo that, is if you go to the partial option, when you pick the edge that you want to chamfer with the partial option, helps if I pick it. What I can do now is I can actually start to drag this chamfer and only do a portion of this edge. And previously this would have been some kind of crazy sweep or some type of extrusion that you would have to create to not chamfer that entire edge. So this works for internal and external. So I can come in here, I can do a partial chamfer. So if I don't want to chamfer that whole piece, I'm just doing this with the handles. I could come in here and I could actually do the chamfer, the start, the end, the total length, whatever you want. So a really easy way to create pretty complicated geometry, because the alternative to this partial chamfer, again, is more than likely like a revolved component here, or maybe a sweep. So this partial chamfer will save you a ton of time. Within just the regular chamfer command, a couple different options. So by default, the chamfer that it is doing is an equal distance chamfer. So it takes 0.125 and goes equal distance. I could do two different distances, or I could do a distance and an angle. So whatever you happen to know about your component or the geometry you're creating, you have some different options inside of Inventor to create that. So again, partial chamfer is only Inventor 2018, and I don't know about you, but whenever I've used previous versions and I needed to create a partial chamfer, this would have helped a ton. The cool thing about the partial chamfer, I didn't even show this, is you can actually do a partial chamfer on a partial chamfer. So I chamfered that one. I can actually come in here and I can do a chamfer on a chamfer, pretty easily to create some pretty cool geometry. So so that is the fillet and chamfer. I'm going to leave the last 2 or 3 minutes for a few questions, if anybody has any. And then don't forget, come back next week. We're going to wrap up with some of the patterning tools, and we'll talk about direct editing as well. That is a huge piece of functionality that if you're not using direct edit, not only for imported or non-native geometry, but I use direct edit a ton on just the Inventor models that I'm making. So we'll talk about direct edit, we'll talk about patterning, and next week is probably going to be our work plane, work axis, work point clinic. So those of you that want to know how to use them and place them and create them, that's going to be a lot of what we talk about next week. So wanted to see if we had any questions out there. We happen to have any, James? Do you have any you could make up and just pretend like we have questions, James?
There is one out there right now, and it says, unrelated to today, I see Luke's thread feature is grayed out. Mine is not working also. Can't remember how to enable it.
Thread, so mine is not grayed out. No, it's available. So you have to have Excel installed on your computer. So I know that it uses Excel in the background, so it might be grayed out potentially. I'd have to check, but it could be because you don't have Excel installed. That would be the only reason why I would think the thread. Now, there's really nothing I can put threads on here. Actually, I do have some curved surfaces. What am I saying? Yeah.
It's funny how gray it looks. Maybe we should talk to the UX guys about that.
Yeah, it could just be, it could be there. It just looks grayed out.
Another one that we have, Luke, is, did you remember that dimension command?
Oh, driven. No, you know what? I don't know why I can't find. Oh, there it is. You dog. I did just find it. So real quick, we are going to let's take one of our existing files.
While you're doing that, there's another question about, will you show iLogic in a future presentation, which I'm sure you will.
We will, but that's not going to be Inventor 101. I'm going to do a whole series, and I may have to get some expert help in for that one. I know iLogic, but not nearly as well as some of the Inventor ninjas out there that I know. So we may have a special guest for a week or 2 or 3 to do iLogic, but that will be outside of Inventor 101 because that's a pretty advanced topic. So we will definitely be doing iLogic. Okay, so we were talking about the driven dimension. So when you put a dimension on something, by default, that dimension gets locked in. So I'm just going to constrain this to the origin point. constrain that right there. And then what happens is, if I want to mess with this, there's nothing I can do. I'm trying to drag it. It won't let me do it. One of the cool things that you can do with your dimensions is, let's say I want to kind of drag this around but know what the dimension is. If I pick that dimension and right here, right beside construction line, center point is driven dimension, what it does is it puts brackets around it. And what it means is it's a dimension that just shows what the value is. It doesn't actually drive the geometry. So what I can do now, you see that line turn light blue, I can now keep this 2-inch locked in. So I can't drag this and make it any bigger, but I can now drag this line and adjust it. So this is good. Let's say if you had a component in here, and let's say, this is, 1 inch by 0.5, and now this dimension here, I kind of want this to be like a dimension that I can kind of play with as I'm working. So I'll take these two dimensions, so I'm just going to pick on them, both of them, and I'm going to change those to driven. So now I can take this box and I can say, you know what, I think I want it here. What does that look like? And the cool thing it does is it shows you the dimensional value that it equals. So you can see, okay, that's close to 1/2 inch, that's close to 1.25. So maybe I make that the actual number. So it gives you some flexibility when you are working with your geometry. So driven dimension, lots and lots of benefit using those. So yeah, it's right there. Should be one of the last commands you have in the upper right-hand corner.
Interesting. A couple other things, Luke.
Sure.
One of the other people watching said that they had the grayed out thread command issue before as well, and they just wanted to make sure that make sure you finish your sketch to enable those commands, because sometimes you're stuck in sketch mode and therefore that's still grayed out.
Yeah, yeah.
And then is any sheet coming up as well, and maybe Inventor 201 or 301.
Yeah, I'm not sure what we're going to call it, but we will definitely be talking about sheet metal. That'll probably be a 2-part series all in itself, because if you're using 2017 and 2018, maybe 2016, there's multi-body sheet metal. You can have variable thicknesses of sheet metal. So sheet metal just within the last 2 or 3 releases got a lot more advanced from a functionality standpoint, with the ability to do multiple bodies, multiple thicknesses. So we will, again, that's not an Inventor 101. That's after we finish some of these basics in the next couple of weeks. So. And if you have any ideas, just email me. You have my email, or hit me up on the social medias at Inventor Luke on Twitter, Facebook, Instagram, YouTube. Just put any comments in there that you want, and I will definitely try to get back to you with if it's something we could do on the show. So this is going to be an ongoing thing. As soon as this series wraps up on June 29th, I think it's the last Thursday in June, we're going to do a whole nother series of webinars after that. So this isn't just done with these 5. This is going to be an every Thursday thing to make sure that we stay tuned and check those out. Any other questions before we wrap it up here, James?
Make fillet before finish a sketch. I guess maybe can you make a fillet before finishing a sketch?
Yeah, you can. So inside the sketch panel, there actually is a fillet command, and what this does is this creates just a 2D fillet. So you just basically pick your edges, it makes them tangent,
and just from listening to you in the past, Luke, usually you wait to do that on the final 3D CAD geometry, just for a little more flexibility.
Yeah, it gives you way more flexibility. I mean, sometimes you have to do it here just because whatever reason, but this would be like a last resort kind of fillet. I wouldn't put fillets, I wouldn't put chamfers, any of those kind of small details. I like to do that as a 3-dimensional feature.
Okay, great. That looks like the last one.
And again, thanks for watching, everybody. I appreciate it, and I will see you next Thursday, 2 o'clock Eastern Standard, for more Inventor 101. See you, everybody. Thanks.